Download this code from codegive.com, link in the description below. Table versus matrix in Power BI, a deep dive with examples. In Power BI, both tables and matrices are powerful visualization tools for displaying data. While they both present information in a structured format using rows and columns, they serve different purposes and offer distinct functionalities. Understanding the key differences between them allows you to choose the right visualization for your reporting needs. This tutorial will break down the distinctions between tables and matrices in Power BI, highlighting their strengths, weaknesses, and use cases, along with code examples, primarily DAX, to enhance their functionality. Core differences ***. Here's a table summarizing the main differences. Feature table matrix. Purpose detailed list of individual records summarizing and aggregating data across categories. Structure simple rows and columns, all data is equally weighted hierarchical structure with rows and columns representing different levels of categories. Aggregation limited. Basic summarization available, sum, average, etc., but not inherent to the structure core functionality. Automatically aggregates data at different levels of hierarchy. Drill down not applicable. Rows are independent. Built-in drill-down capabilities to explore data at different levels of detail. Hierarchy none supports row and column hierarchies. Flexibility less flexible in terms of data manipulation within the visual, more flexible in terms of data manipulation and presentation. Use case displaying detailed records, example customer lists, product inventories, analyzing sales data by region and product category, comparing performance across time periods. 2. In-depth explanation ***. Let's delve deeper into each aspect of the differences. 1. Purpose and structure ***. Table ***. A table presents data as a flat, two-dimensional list of records. Each row represents a single, distinct item or entry from your data set. All columns have equal importance in the layout, with no inherent grouping or categorization. It's designed for displaying detail, not analysis. Matrix ***. A matrix is a more complex visual that allows you to summarize and analyze data based on multiple categories. Think of it as a pivot table. It uses a hierarchical structure with rows and columns, where each level of the hierarchy represents a different dimension or grouping in your data. The intersection of a row and column displays an aggregated value based on the specified measure. This makes it ideal for identifying trends and patterns across various categories. 2. Aggregation and drill down ***. Table ***. While you can perform basic aggregations, like sum, average, min, max, on numeric columns within a table using the summarization option in the Fields pane, the table itself doesn't inherently promote aggregation. The focus is on viewing the individual records, not summarized results. Matrix aggregation is a fundamental feature of the matrix visual. When you add fields to the rows and columns, Power BI automatically calculates aggregated values for each cell based on the measures you've defined. For example, if you have a sales measure and add region to the rows and year to the columns, the matrix will display the total sales for each region in each year. The matrix also provides built-in drill-down functionality. This allows you to navigate through the hierarchy of your data, starting at a high level and then drilling down to more granular levels. For example, if you have a hierarchy of region, country, city on the rows, you can initially view the data at the regional level, then drill down to see the individual countries within each region, and finally drill down to see the cities within each country. 3. Hierarchy and flexibility ***. Asterisk tables don't support hierarchies. Each row is treated as an independent record. You can't create nested groupings or drill down to different levels of detail within a table. Asterisk matrices are designed to handle hierarchies. You can define hierarchies in both the rows and columns of the matrix, allowing you to explore your data from different perspectives. This is crucial for analyzing data that has natural hierarchical relationships, example geographical regions, product categories, organizational structures. The matrix also offers more flexibility in terms of data manipulation. You can easily add or remove fields from the rows and columns, change the aggregation functions used for the measures, and apply conditional formatting to highlight important trends and outliers. 3. Code examples, DAX. While tables themselves don't directly involve DAX for their structure, DAX is critical for calculating the measures used in both tables, for summarization, and matrices. Let's focus on examples that enhance the capabilities of both, but are especially relevant for matrix calculations. A basic measure for sales asterisk. This simple measure calculates the sum of the amount column in the sales table. You can use this in either a table, via the summarization option, or a matrix. B measure with filtering, for both table and matrix. This measure calculates the total sales for the year 2023. It utilizes the calculate function to modify the context of the total sales measure by applying a filter. This is useful for comparing sales in different years within either a table or a matrix. C. Measure for percentage of total, especially useful in matrix. This measure calculates the percentage of total sales for each category displayed in the matrix. All selected, sales, removes any filters that have been applied to the rows or columns of the matrix, allowing you to calculate the percentage of the grand total. This is particularly useful in a matrix to see how different categories contribute to the overall sales. D. Ranking within a category, especially useful in matrix. This measure calculates the rank of each product category based on the total sales. All selected, product category, ensures that the ranking is performed within the selected product categories, regardless of any other filters that have been applied. This is very valuable for identifying top-performing categories in your matrix. E. Calculating year-over-year growth, useful in matrix for time series analysis. This measure calculates the year-over-year growth in sales. It uses variables to store the sales for the current year and the previous year, then calculates the percentage change. Dated, sales date, -1, year, shifts the date context to the previous year. This is extremely useful when you have time periods, example years, quarters, months, on the columns of your matrix. 4. Practical examples ***. A table example, customer list. Imagine you have a table of customer data with columns like customer ID, first name, last name, email, city, and order date. You would use a table visual to display this information directly. 1. Drag the table visual onto the Power BI canvas. 2. Drag the fields customer ID, first name, last name, email, and city from the customer table in the fields pane to the values section of the visualizations pane. The table will display a detailed list of your customers, allowing you to easily see all the information associated with each customer. B matrix example, sales analysis by region and product category. Let's say you have a sales data set with columns like region, product category, sales amount, and date. You would use a matrix visual to analyze sales performance across different regions and product categories. 1. Drag the matrix visual onto the Power BI canvas. 2. Drag the region field from the sales table to the rows section of the visualizations pane. 3. Drag the product category field from the sales table to the columns section of the visualizations pane. 4. Drag the sales amount field from the sales table to the values section of the visualizations pane. The matrix will display the total sales for each region and product category combination. You can then drill down into specific regions or product categories to see more detailed data. C. Using DAX measures in the matrix ***. Continuing from the previous example, let's add the YoY growth measure to the matrix. 1. Create the YoY growth measure as defined in the DAX examples above. 2. Drag the date field from the sales table to the columns section of the visualizations pane, if you don't already have a date-related field there. Make sure it's set to year level. This is crucial for the datehead function to work correctly. 3. Drag the YoY growth measure to the values section of the visualizations pane. The matrix will now display the year-over-year growth in sales for each region and product category. This allows you to easily identify which areas are experiencing the most growth. V. Formatting and customization ***. Both tables and matrices offer a wide range of formatting options in the Format pane of the Visualizations pane. You can customize the appearance of the visuals by adjusting the following. **style **. Choose from different predefined styles to quickly change the overall look of the visual. **column headers **. Customize the font, background color, and alignment of the column headers. **row headers **. Customize the font, background color, and alignment of the row headers. Especially important in matrices. **values **. Customize the font, background color, number format, and conditional formatting of the data values. **grid **. Control the appearance of the grid lines. Conditional formatting **. Apply data bars, color scales, or icons to highlight important trends and outliers. More applicable to matrices. Total ** show or hide totals, and customize their appearance. Crucial for matrices. Subtotals ** control the display of subtotals and grand totals for different levels of the hierarchy in a matrix. 6. Best practices for choosing between tables and matrices ***. Use tables when ***. You need to display a detailed list of individual records. You don't need to aggregate or summarize the data. You don't need drill down functionality. The data doesn't have a hierarchical structure. Use matrices when you need to summarize and analyze data across multiple categories. You want to explore data at different levels of detail using drill down functionality. The data has a hierarchical structure. You need to calculate percentages, rankings, or other complex measures based on different categories. You need to present data in a tabular format with aggregated values. 7. Conclusion ***. Tables and matrices are essential visuals in Power BI, each serving a distinct purpose. Tables excel at presenting detailed data records, while matrices offer powerful summarization and analytical capabilities. Understanding their strengths and weaknesses, along with the strategic use of DAX measures, empowers you to create effective and insightful reports that meet your specific business needs. By mastering these visuals, you can unlock valuable insights from your data and make better informed decisions. Experiment with both visuals and the DAX examples provided to gain a deeper understanding of their capabilities and how they can be used to enhance your Power BI reports.